The next speaker, Matt St. Pierre, is a sales engineer with Communications International, which is based out of Vero Beach, Florida. Matt has been with CI for 22 years, the most recent in Charlotte, North Carolina. For the first 15 years, he was the field engineering team responsible for the implementation of GE modem and RS-232 vintage analog EDAC simulcast systems, and later GPS-based EDAC simulcast systems, continuing on to Harris's P25 digital, microwave, IP networks, conventional, paging, and simulcast networks. He got his start in communications in the Navy for 10 years as an air crewman on board a Navy airborne command post and communications relay aircraft platform, specializing in encrypted voice and data communications. Communications International is a major integrator of Harris-Tait LMR-based communications networks, including public safety. It is an employee-owned company which has been in continuous operation since 1975. In Orlando, we did have a glitch in the recording, so we're going to pick up the video on slide 2.
So this is obviously with the front panel off. We got the PMU over on the far side there. We've got the power amplifier in the middle. We've got one channel 100 watt capability on the left. We've got 2 channels of 50 watts on the right, and up to 4 channels receive only in one chassis. So it's also got a little thing that flew in there. Cool tool. It's got a built-in spectrum analog. So all you nerd types like me, it's a fabulous tool to be able to remotely watch interference issues or whatever to see what the base station sees. Sorry. So tape analog simulcast over IP, ASIP. Again, excellent system migration choice. Analog, and again, the example I'm going to talk about in a minute, when they're in analog mode now, but their goal is to go P25 in the future. Again, full reuse of hardware and software licensing, and indeed the hardware in that box. Up to 14 sites per channel group. Native IP-based solution. Of course, small footprint. That box is 4 rack units. Network management, a little redundancy there. Excellent paging platform. We've got these things deployed all over the place for paging overlays on P25 simulcast system. So, why simulcast? And I had my man Joe there going to simulcast theory, so I wouldn't have to. I could sit here and talk about what I want to talk about. Great job, Joe. So why simulcast? Well, we can efficiently reuse the frequencies at adjacent sites. A simple simulcast diagram there. Balanced coverage in both talk out and talk back. Receiver voting, again, that's built into the base station. There is no external voting components. Seamless wide area coverage. Supports analog, digital, P25, and a similar platform as the TB9300, which also supports DMR, or analog DMR all the way up to simulcast. That's the TB9300 platform. Essentially, the only difference there is the modules, the internal modules, and the software, of course. So, and the biggest one, right, to the first responders and users is it eliminates the need to switch on their radios. I just got into the capture area of this site. I got to switch my radio. I got to go further down the county. I got to switch to this site. That's what the case study is doing now that I'm going to go into in a few minutes. So a little chart here, and I just want to point out, this chart is a little on the conservative side from the designing standpoint. We always like to stay on the conservative side. So the numbers that you see, for example, the delay spread tolerance on analog, and then you can take that out a little further, obviously. Same thing with LSM. This is a tape chart, so they're gonna want to be a little conservative as well. But the purpose of the chart is to just show you, site separation versus modulation format. And all that stuff. So what you've got is analog has really always been very forgiving in the overlap, right? Well, P25 C4FM is half as forgiving, but LSM takes it out and gives us a lot more tolerance. So in essence, you can increase your site separation with LSM. That's the purpose of the chart. So this is a basic ASIP network. So as you can see, we've got the Tait base stations at its core. We've got GPS timing units, which we use Spectracom's Secure Sync. We use the 1 pulse per second, 10 meg reference or 5 meg reference, and NTP for time standard. We can also add a console interface, analog console interface, and you can see through a console gateway there. All that is a gateway in between the IP world and the four-wire interface, so that the base station can get the IP packets that it needs. Or you can just do an air interface console dispatch solution that are using telex at this time.
Does the system allow for more than one console gateway?
Yes.
Thank you.
Yes. If you want some more specs on that, let me know and I can get them for you. So getting a little more complex on our network, we've got our ASIP network with a hub and spoke type of arrangement. And again, it's all IP links, right? Just kind of spread around from the previous slide. And then, of course, our loop network. So loop microwave, loop fiber, however you want to look at it. So our case study in this particular session is for Marshall County, Tennessee. And we used Marshall County, Tennessee for a few reasons. But like I was saying, we partnered up with our dealer partner, Middle Tennessee Two-Way. And they are the ones that actually deployed it. So you can see by the shape of Marshall County there, it's kind of shaped like a vase, or a vase, however you want to say it. But it's kind of ideal because the county is longer than it is, wide, except for down there at the bottom where you've got those bulges on the bottom, so hence the shape, the vase shape. It's a fairly small county as far as number of users. I can't remember the total number of users on this thing, but the county population is like 20,000 or something like that, 40,000. It's not very big. It's only like 500 square miles. So their legacy system, quick snapshot of that. It's all analog. It's 3 sites consisting of 3 repeater channels at each site. Again, the big one there is users had to manually switch between sites. They just outgrew it many, many years ago. Non-Simulcast, and user access was managed with CTCSS nodes. Remember the old community repeater days, right? Lots of coverage holes. And the customer had no roaming capability, obviously, and no possibility of migration. Just a dead end, no possibility of going to P25 with that. So their unique needs, and this wasn't all the needs. I actually thinned down the slide a little bit. But they want to maximize coverage with existing sites. That was really the key design parameter that they gave us to go by, was we have to use our existing sites for now. And as we grow, I'll show you another slide with the coverage here in a second, but as we grow, we can fill in some of the areas that don't have coverage now that are in rural areas anyhow, and the main part of the coverage covers the main populous areas. So we're going to stick with that for a while, and then in the future, as we need to add sites, we'll do that. They wanted seamless wide area coverage. They wanted to future-proof their system. In other words, they wanted that capability, that path to migration to P25, whatever form that'll take. They also wanted to do this in a phased approach, because we all know that, in a time of shrinking or small budgets, this Tait product, analog simulcast in general, is you used to hear analog is dying. It's alive and well in the southeast, I'll tell you that. So the phased approach was probably the second biggest design parameter of this. They wanted to start off, and I'm not really going to go into it too much, but they started off with telex dispatch. They added that to their current system. And then they went to, get into this a little more, but they upgraded their microwave links. And then came the Tait ASIP, which was implemented in the October, November timeframe. So low risk, in other words, simplicity, high performance. They needed stability and reliability out of this, and low total cost of ownership. That was probably the third biggest design parameter, was they had a budget. So again, we partnered up with our dealer partner, Middle Tennessee Two-Way. We assisted with coverage modeling, antenna designs and patterns. We used Raptor coverage modeling product. Equipment configurations, pricing and ordering, and of course technical support. We support all our dealers in any way we can. So a quick look at the new ASIP system. It's analog simulcast, and I put in there for now because the customer doesn't want to stay analog forever. They want to go to P25. It consists of 3 sites of UHF, 1 channel each site. For MCSO is the Marshall County Sheriff's Office. So law enforcement is on basically 1 channel, and 3 sites of VHF for fire EMS countywide. So it's basically an overlay of 2 simulcast systems, a UHF system using the same sites as the 3-site VHF simulcast system. I added a Cielo Networks IP backhaul and got that ready for the integration of the all-IP ASIP simulcast system, and a new antenna configuration, which involved directional patterns as well as omnidirectional patterns. So this is a coverage map, the way that the system exists today. After implementation, it's covering pretty well. Like I was telling you, the bulges on the side of the base there are areas of, well, especially the one on the right, there's a ridge line in there that was made it very difficult to cover. And actually in that area down there, if, adding any one site, this is another design challenge, because of the terrain, it's a terrain limited system, terrain limited network coverage. That lower right bulge, to fill it in the way that you would want it filled in, you'd probably have to add a combination of 2 sites down there. It's just the way the terrain, the ridgeline, valleys, rivers, all kind of, dense foliage, very rural, made it a challenge. And the gains that you would get from adding any one site down there was very small in relation to how much money you're going to spend putting a site down there, right? So the customer said, okay, we'll use the 3 sites we got. Tell us what you can do with, patterns and simulcast and all that stuff, and see where we'll go. And then in the future, we'll, add sites and infrastructure as required, or redesign the network. Of course, use LSM, which, might help. So the green is coverage, and I think we've got our threshold set for like neg 100. Project sensitivity is about neg 100. So I could have gone a little looser on the threshold on the sensitivity, but I believe it's neg 100. So basically, what you're looking at is green is neg 100 dBm or better. Typically, you can go out to neg 104, neg 106. Depends on the radio, right? The brown regions there off to the left side of the base and a little bit in the right side, that's simulcast overlap, noise, TI. So we were able to manage that with antenna patterns by pushing some of that out of the county. And then a little bit down there on the right, which the interesting part about this is, well, as I said before, we try to stay conservative on our designs. The actual coverage on the street is a little bit better than this, because of the project sensitivity for one, but because of our conservativeness when we're running these, the dealer actually tested it. And I wish I had drive test data for this, but I simply don't. They're reporting to us that their findings as well as the user's findings are actually better than this. So it worked out very well. So that's Marshall County. So to time the system, I mentioned we're using Spectracom Secure Sync. And we've got 1 on each site. Each site is a full transmit receive site. So we need 10 meg reference. We need 1 pulse per second. And as I indicated before, NTP for timestamps for logging and that good stuff. So we were able to get our secure syncs from Ed and of course base stations and stuff from Tait. Their IP backhaul, they're using Cielo networks, which I have no personal experience, maybe some of you all do. It's a Skylink CG2, compact gigabit Ethernet point-to-point radios, packet radios, at 11 gigs. They're licensed for 10 megabits per second, which is way more than enough to transport what we need for our analog voice channels, which are somewhere around 50 kilobits per second or something like that. It's very low bandwidth. It's an indoor-outdoor split package. And they're using just commercial off-the-shelf switches. It's not a routed network. It's just simple switches. We're not even using VLANs on it. Just using Ethernet transport over, simple unmanaged switches. So bits and gotchas, as there is with every project. In particular with this one was the dealer was saying that he put the transmit antenna under the receive antenna, and that was fine, it worked, but they got some kind of element of shadowing up close to the tower because of that. So the lesson learned was swap them back around, put the transmit on top, and get rid of that shadow footprint that they were getting close into the tower, and it cured that problem. That was a hard lesson because tower crews are expensive. You all know that. Also, emphasis on staging, even on small systems. We helped him stage this particular system, and that's why I'm putting it in there. These things they're fairly simple to deploy, but staging it's a key element to deploying these things. I mean, you can get them talking on a simple network. You can do the basic settings on them. I mean, you're not going to do wide area Simulcast coverage and testing with it, obviously, but you'll be able to at least put some kind of testing and get some debug out of the way. Put the initial configuration level set on it. They did experience some early on audio issues. And it turned out to be, the timing, everything was good. The propagation was good. Their antenna patterns were good. We went in and out of it for about 3 to 5 days. What it turned out to be was they had a setting in the base stations, and on this particular one, it was the site way up north there. There's a setting called audio response or something like that, and the checkbox was literally checked for flat instead of de-emphasis on the audio. So it was weird because driving around, it sounded like overlap noise, interference. And it just really it was causing a lot of audio issues, and that's why we kept going back to the drawing board, back to Raptor, saying, all right, what is going on with this? Our antenna patterns are good, our delay is good, everything should be good, the Marshall delay setting that we put in, everything should be good. The RF levels were good for the overlap, to control the overlap. What is going on? And we just backed up, went through all the settings, and checkbox. It's amazing how the checkbox is. So, post-implementation summary. Overall, as the predicted improvement, they had predicted improvements over what they had, and in some of the cases on those bulges of the base were actually better than we had predicted. So improved countywide coverage in both VHF and UHF. They still do have some pockets of indoor coverage, especially on the VHF side, that they're lacking. There are some holes, but overall it's still better. It's what the county expected and then some. They do plan to add towers in the future to fill in some of those areas as they move towards P25, or may not need to. Antenna patterns and LSM and stuff. So overall success, customers satisfied. They can talk seamlessly from one end of the county to the other without fooling with a radio, which was the biggest thing. They now have a software upgradable platform. They're analog now, but they can go all the way to P25 Phase 2 if they want in the future, with software upgrades to the base stations, and of course they want to go trunking. You have to add trunking controllers and RFSS and all that, core switch, all that kind of stuff. They now have a migration-friendly modular platform at a price point that they can budget in pieces instead of a forklift upgrade.